This is Mr. Weideman, and this is Regular Physics, Lafayette High School. This is problem number 55 on your planetary motion and gravitation problem set. And let's take a look at this problem, and I'm actually going to solve it two different ways. First of all, we need to set up the problem. Let's visualize what the information that they're giving us is. And first thing I did is on the problem I converted all my distances to meters. And the reason I did that is I'm going to use Newton's version of Kepler's laws. So I need to be compatible with G. And what am I doing? I am orbiting the moon. Okay, so that is going to be my center of orbit. And so I'm going to make all of my data in relationship to the center of the moon. Okay, so I am adjusting my altitude above the surface, this 111,000 meters. So now my total radius of orbit will be the radius of the moon plus the altitude. What velocity did it orbit the moon? Okay, so I can use, we derived this equation in class for velocity of a satellite. And in this case, I'm orbiting the moon, so that I need the mass of the moon. And my radius here is the radius of the moon plus the altitude. So I can get my tangential velocity. And then from my tangential velocity to get my period, I know an alternate way of calculating tangential velocity is a circumference. So there's the circumference of my orbit divided by the radius of multiplied by the radius, which I just found. Okay, and then I can back calculate then my time period. Once I found my velocity tangential using this equation, then I can back calculate my time in seconds. An alternate way of doing this is I can just use Newton's version of Kepler's law. Okay, I can get at this time period directly right here. Just remember that when I calculate this, I'm going to be in seconds. And then what I can do is I have this time in seconds, and I can substitute it back in here, and then I can get tangential velocity. Either method will work just fine. Just watch your units and your conversions very carefully, and watch your algebra using this equation, and everything will turn out just fine.